questions from that quiz? Not sure what your questions were.
We did do number 1.
So number 1 was the parabola. Half of you guys had a parabola that was facing down, and the other half parabola was facing up. All right. So some of you guys should have had a directrix down here, and the rest of you should have had a directrix up there above the y-axis. You didn't have to use focal diameter. It didn't say anything about focal diameter, but you could if you wanted to, as long as you made your scale work. Right? You could just get another point somehow.
For x is 0, 0.
Yeah, the origin for everybody should have, the vertex for everybody should have been the origin. Yeah. It wasn't shifted. None of these were shifted except the very last one, and that one I didn't even make it graph. Alright, so I was trying to make this one very, very, very nuts and bolts. Yes, ma'am?
Was the last one a circle?
For some of you? Yeah, well, no. Nobody had a circle. Half of you had an ellipse and half of you had a hyperbola. It wasn't a circle because the coefficients were different. Somebody had a minus, that's hyperbola. Somebody had a plus, coefficient's different, that's an ellipse. How can you tell before you do anything?
Minus.
Yeah, plus, so you get an x squared minus 2y squared equals some number. That's going to be a and hyperbola, depending on the right way you want to say it. That's a. And that would be an ellipse. Cool. I like it. It's crazy. And that would be a circle, because they're the same coefficients. Cool. I like it.
And if there's only one term squared, then it's a parabola.
Yeah, exactly. If the highest part on the x was 2 and the highest part on the y was 1, that would be parabola.
And that's a parabola that faces upwards.
Depends on what the other stuff is. Well, yeah, if this is the only y term, you would collect, so you move that over, it'd be negative. So it's going to face down. I didn't give you guys one that weird. It was supposedly, hopefully, very straightforward. That's what I was shooting for. Okay. Anything else from that quiz? Anything from homework? I finally put 12.1 through 12.3 up on WebAssign.
Did you go through your last homework assignment?
At the moment. I get too excited. It probably will be time. 12.5 is just so, the minute I say I like it, I know you guys are going to be like, all right, then I'm glad we're not going to do it. But math induction, mathematical induction, is a powerful proof tool. But it all depends. If you guys, how many of you guys remind me 280? 280 people? Anybody has to go to 280 at least? All right, you will revisit that. So you might want to take a little preview of math induction. That will be not a big part of 280, but it's in there. All right, math induction is awesome, even though it sounds like some kind of dental procedure. You're going to induct your math. Oh, shit. Or some kind of electrical circuit thing or something. All right, enough of that shit. All right. Any questions from the homework we did? From the section we did? We sort of did all of them, to be honest. I just got to come back in and fill in some details. 12.1 was the generalization of sequences. We're going to do series a little bit today. And then 12.2 and 12.3 were specific series, geometric and arithmetic, and both of those came up. Both of those we've already kind of looked at. Yes, sir?
So we're not doing section 12.5, or are we still doing it in the class?
No, we're not. Yeah, I might give you one example. And math induction is one of those things that's very frustrating for a teacher because either it clicks or it don't. A lot of things are like that, but math induction is exactly that. Either you get it or you completely don't. And it's so frustrating. And you guys are like, what's even more frustrating? But, yeah. But I might give you an example of it. This is just so damn awesome. Okay. But what I want to do is fill in some blanks. We didn't really talk about the second part of this handout. The summation notation. Sigma notation. This letter here is the Greek letter sigma. remember now, I might have said something about this. Why did the creative math people choose this letter to represent sums?
Because it starts with an S.
Because it's the Greek letter S, actually, yeah. It said, for sum, let's use S. Hey, you're awesome. So you might know this symbol from fraternities, sororities, or something maybe. Sigma, sigma, sigma. Or not. That's uppercase sigma, lowercase sigma is that, and if you've taken any statistics, you know that really well. Right? And obviously, if you've taken statistics, you know this guy really well too, you should. So you're a little ahead of the game. So here's how this symbol works. If I wanted to, let's see, you could do it, Jeff. If I wanted to do like 3 plus 6 plus 9 plus 12, I just wanted to do that forever. What kind of sequence does that represent? Yeah, just keep adding 3, right? So can you come up with the sequence definition for this? What's AN?
N plus 3.
Careful. It's not. It definitely can't be N plus 3. 3n, good. I mean, now watch. You can kind of you can either use the official definition, which is this one. It's the official formula. That's it. That's the official formula, right? So let me use that real quick, and then I'll just show you how to do it much better and much quicker. All right. The better you're able to play with numbers, the easier everything should be. The less you should have to do. So this is the official thing. What's the first term? That's great. N minus 1, because I don't know what n is. And then what's d? 3. So I get 3 plus 3n minus 3, I get 3n. Right? And the reason this one's easy is because it's not shifted by, it is exactly multiples of 3. So it's almost a definition. It's 3n. So if I had something where I kept adding 4, so if I had one that was, let's do 5 plus 9 plus, you can do it, Jeff. There you go. That's not 4n, is it?
4n.
It's 4n plus 1, yeah, because they're all up 1 from 4n, right? Do you guys see that? So you don't have to use this if you don't want to. It's there if you want it, if you need to. If you have some funky d, like d is negative 8/7, I'm probably going to use this just to set it up, right? But if it's this, it's just 1 off from 4 and 8 and 12, it's just 1 off, so it'll be 4n plus 1. Maybe. So you've got the official definition you can always use whenever you want to, but there's almost always a quicker way to get there to the equation. I like it. So if I wanted to represent this sum quickly, right? Tell somebody to do this and they'll have to write out all that crap. I can say I want to sum 3n from what to what? From n equal to what up to n equal to what? Yeah, from n equal to 1. Now be careful. To infinity. Yeah. Now obviously that sum would be what? Infinity, right? 3 plus 6 plus 9 plus 12, that's going to infinity itself. So when you add them all together, it's like even more infinite. Right? Super infinite. Maybe. I think I said infinity, which is actually not what that means. Okay, cool. So here, let me give you one of these guys without a sequence attached to it. So how would you do this? What does that represent?
First 5 numbers.
Good. All right. The first 5 elements of that sequence have to be added together, right? So this is the definition of a sequence of numbers. The minute you put that symbol with it, that becomes a series. A series is the sum of the parts of a sequence. This is crazy important for those of you going into 280. That's what kills people in chapter 11 and 280, is they cannot keep those things separate. Sequences and series, they act differently. So how the hell do I do this? Why was that easy? If I wanted to do from n equal 1 to 4, I just add these things up, right? Well, I gave you this. Well, this time I gave you this, so how do you get the numbers that I'm adding up? Plug that's crazy. So plug a 1 in, you get -1 plus. When n is 2, you get 2 plus. When n is 3, you get 7 plus. When n is 4, you get 14 plus. When n is 5, you get 22. It's crazy. It's crazy. It's crazy. And then you get whatever you get. 45. Sorry. Yeah.
So if you didn't have the 5 on top, would be series?
No. This is a series. This is a partial sum. Why do you think I call this a partial sum? That's the full sum of a series. It's a partial sum because it only goes up to 5. Right? A sequence could officially go forever. So a full series, a full sum would be the whole thing. This is what I call as a partial sum. Yeah. But a series involves addition. A sequence involves commas. Right? It's just a list. That's the difference. All right. Cool. How are we doing so far? All right. The summation symbol is not really bound by the same rules. Let me show you what I mean by that. I could go from -2 to 3, for example. You could do it, Jeff. Can you, Jeff? Yeah, sure. I over I plus 3. And once you get the idea, I could throw almost anything at you. It's really just a combination of plug and chug, and then add the stuff you just chugged. Sounds strange, but so what's the first element of this series that I got to sum? Yeah, you get -2 over 1, so you get -2 plus. When I is -1, you get -1/2. When I is 0, you have 0. That's great. You guys loopy? This is I equal -2. When you plug a -2 in, you get -2 over 1. This is -2. When I is -1, because I'm going between these two, right? When I is 0, when I do be 1, 1/4. When I is being 2, 2/5. And when I is being 3, 1/2. I like it. So let's do the sums. Bam, bam. So you get -2 plus whatever. 13/20s, so -27/20s? Nobody's going to help me? Alright. Yeah, you're doing fine. So this is 5, 8, 13/20s minus 40/20s. What is it? 13/20s minus 40/20s is -27/20s. Back. Alright. So what's important again is, of course, the idea. What does this represent? That symbol, what does it represent? What does it tell you to do? Okay. Sum. Sum up what? Whatever the hell's in there. Between this and this. I like it. I like it. I like it. This dude is going to rule your life in calculus for the first half of calculus. Just about. Really. Alright. Okay. Only thing, is there anything else weird? No. So, I mean, normally the things we use for the index, and this is the index, it kind of makes sense to use I for index, but we also use J and K. So, I, J, K. We like using those for summations and reasons. What's up?
You're just kidding.
I am just kidding. No, I'm not. Yes, I am. I, J, K. Alright. So real quick remind me, which kind of sequence is this here? What kind of sequence is that?
Arithmetic. Could it be arithmetic too?
Do you guys remember the one that involved multiplication was called geometric? The one that involves addition is arithmetic. I like it. It's awesome because it starts with an A, right? So this is arithmetic. And the formula for the nth term of it is well known. It's this little dude, right? That's the one we just used earlier. It's going to be 4 total formulas that involve arithmetic and geometric. They're each going to have an AN, and they're each going to have an SN. What do you think SN would represent? Sum of. So it would be partial sum. Sum from 1 up to whatever n is. I like it. So have I told you this story yet about Gauss, the urban legend in math about Gauss? And he was in a classroom and they were driving their teacher crazy. And the teacher said, shut up, sit down. You will. I don't know why it's so. It's like some weird Arnold Schwarzenegger play. You will add up. Listen to me. You will add up the numbers from 1 to 100. He thought that'll keep him busy for a while. Do it or you fail. And they're like, shit. So he thought it'd take him, 1 plus 2 is 3 plus 3 is 6 plus 3. He thought, well, that's going to take him a while. And he sat down reading his newspaper. All right, they existed a lot more back then. But the little Gauss dude, he came up and he says, I'm done, about 10 seconds later. I'm done with this busy work shit, teacher. Can we actually talk about something? You guys with me? Mm-hmm. So how the hell did he do it? How the hell did he add them up so quickly?
Segmentation.
No, actually, no, he didn't. He totally bypassed that. He's like, I don't like Greek. What's up? He came with a formula. It's crazy. I love it. This guy's like, I'll tell you what he did. I don't know how he did it. But here's the cool thing. What's 1 plus 100? 101. What's 2 plus 99? 101. How many times is that going to show up? 50. 50 times. So what he realized was, if I have an arithmetic sequence, A1 plus AN will be repeated how many times? So if I have n terms,
Half of it.
A1 plus AN will be repeated n over 2 times. That's how many pairs there will have to be. Don't worry if there's not an even number of terms. The middle dude just goes by himself, right? He's the single guy. Aww. I don't know if you guys are with me at all. So here, 1 plus I, blah, blah. The formula then for SN will be, I've got A1 plus AN, 1 plus 100, is repeated n over 2 times. That's the formula for a partial sum of an arithmetic sequence. Supposedly it came from a little grammar school Gauss showing off. He went on to do way too much stuff for one person. I think he was several people. Or he was an alien or something. I don't know. So there's AN, this is for arithmetic. SN, that's for arithmetic. Notice the way we say that. Now here, you guys try that out here. Let me see if you guys are able to handle this. Given what you want. That's 17, yeah. While you're doing that, I'm going to give you guys, I went ahead and printed out the practice final exam. We'll be going over this starting Wednesday. Still good. So I'll make sure we got the first couple right. We try to do this the shortcut way. What's the common difference? 5. So I know it's going to be somehow based on 5, and that ain't 5, it's 3 less than it. And anytime you do that a different way than the given textbook formula, just take a second and say, like, the third one is 12, 5 times 3 is 15, minus 3 is 12, yay! So just check real quick, make sure you get a later term. Right? If you did it the other way, you should still come out to this eventually. What's A18 then?
87.
87, take guess. So how do I do S18?
19.
Yeah, 18 divided by 2, that's how many pairs of the repeated sum there's going to be. And the repeated sum is going to be...
So 2 plus 87.
Yeah, the first term 2, plus the last term 87. So real quick, just in case you didn't understand what that meant, all right, if that was 17, this would have come out even, so that 2 can go into it. Do you guys with me? If there's no fractions in your sequence, then your answer should be a whole number, right? So if that's not even, this is going to be even. Does that make sense? If not, do it, you'll be fine. And then you get what, 9 times 89. I never did finish that one out there. Who is it?
801.
801? Okay. Hey, real quick, I'm sorry, we never did this one. What's 50 101s? It's awesome. The sum of the first 100 natural numbers is 50/50. That's kind of awesome. You got it. You got to admit that. Hey, whatever, Jeff, sure. Whatever lets me get out of here. Alright. And on that note, that's plenty for today. So tomorrow we'll focus on geometric. And then Wednesday, the next Wednesday and Thursday will be review days. In here.
How long is the test?
The finals, 2 hours.
20 questions?
Didn't they use what?
20 questions?
I don't know. What did I say? Not last semester, a long time ago. That was beautiful for teachers. On the student is like, oh, really? They designed a 3 hour Not long after I first came here, they stopped doing it. Like in 06 or something like that.